Yeah, students, let us say a small part from electrochemistry, class 12. Now, here we are trying to find out electrolysis of some of the aqueous and the molten solution and the product obtained at anode and cathode. Electrolysis of some aqueous and molten solution. Let us see what product we get at anode and cathode. Very popular question for JEE and NEET objective exam. So let us start first with a simple one. Suppose I take aqueous NaCl. What product do we get at anode and cathode? Now when I say NaCl, it is Na plus and Cl minus, right? So this Na plus will take one electron and deposit as sodium at cathode, correct? And this we have got Cl minus, which will lose an electron to give Cl, and in fact 2 Cl will become 2 electron. This is what is going to happen at anode. But when I say the solution is aqueous, that means I have also got H plus and OH minus. Now this H plus can accept electron to deposit as hydrogen, and OH minus will form O2, some undissociated molecule of water and electron. To balance, I will put up 4 here. Now the question is, we have got 4 ions. Positive ions will go at cathode and negative ion will go at anode. It is very clear. So question is, out of these 2 positive ion, who can undergo reduction faster? Out of this positive and this negative, who can undergo reduction faster? So we know that potential of hydrogen H plus to accept electron is more. In fact, sodium is like metallic, so Na plus has already lost its electron. So gaining property for H will be more as per the EMF series, and that is why anode product is going to be hydrogen gas. And now the cathode product. So this is a trick here to understand कि at cathode, out of Cl minus and out of OH minus, which ion will go. See, whenever we have a single ion, like Cl minus is a single ion, but OH minus is a group of 2 atoms, right? So in group you are more stable, you become more heavy. So therefore migrating towards anode is difficult if it is a group compared to a single ion. So out of Cl minus and OH minus, Cl minus will migrate faster to anode, and therefore to cathode, and therefore this is cathode here, correct? And now I am talking about anode. So at anode I will find that Cl2 will be liberated. Please remember, electrolysis of aqueous NaCl solution will give hydrogen at cathode and chlorine at anode. So for Na plus and H plus has got a higher reduction power, therefore H2 will be liberated faster, and out of the Cl minus and OH minus, that negative ion, which is a single ion, will migrate faster towards anode. That means its oxidation potential is higher, and that is why at anode product is Cl2. Now suppose if I take molten NaCl. Molten or fused NaCl means there is no water, it is just liquid state NaCl. So there is no confusion at all. I will have Na plus and Cl minus, and at anode chlorine will go and liberate, Cl minus will go and form Cl2, and at cathode Na plus will deposit as sodium. Same reaction as what we have written here, right? So there is no problem with that. Instead of this, suppose I take second part, C part, suppose I take aqueous copper sulfate and electrolyze this. So in the aqueous copper sulfate, I will have copper plus 2 and SO4 minus 2. So also H plus and OH minus. Now the question is, out of copper plus 2 and H plus, see this positive ion will go at cathode, right? And negative ion will go at anode. We have to decide, out of copper plus 2 and H plus, who will go at cathode faster. That means who has a higher reduction potential. So as per EMF series, copper has more positive reduction potential than hydrogen. And that is why at cathode, copper will undergo reduction to deposit as Cu. This is the cathode product. Now, who will go at anode? See, I have got OH4 minus, SO4 minus 2 and OH minus. So, SO4 minus 2 is a bigger group. Compared to that, OH minus is a smaller group. So, OH can migrate at anode faster. And this OH minus will form what? O2, H2O plus electron is liberated, because at anode it is oxidation. To balance, I'll put a 4 here, 2 here and 4 here. Thus, cathode product is copper and anode product is O2 when you electrolyze aqueous copper sulfate. Now, instead of aqueous, if I take molten CuSO4, then what is the product? Then there is no water, right? It is just copper sulfate. So, this copper will deposit as, copper plus 2 will deposit as copper at cathode. So, at cathode, Cu plus 2 will take 2 electron and deposit as Cu. At anode, SO4 minus 2 is there. So, that SO4 minus 2 will get converted to SO2 plus O2 plus 2 electrons, right? Because now there is nowhere OH minus. Similarly, suppose I take H2SO4 aqueous. So, what do I have? H plus SO4 minus 2, water H plus and OH minus. So, at cathode, what product do you expect? Now, there is only one positive ion, that is H plus, which will liberate as hydrogen gas. And an anode, who will go? Out of SO4 minus 2 and OH minus, OH minus is a smaller group, therefore that will go at anode first and will oxidize to give what? O2. So, aqueous H2SO4 will give H2O2. So, it looks like water is undergoing electrolysis, correct? If I take molten H2SO4, that means there is no water, just H2SO4. So, I will have only H plus and SO4 minus 2. So, cathode product will be same, that is H2, and your anode product will be what? SO2 and O2, just as the earlier reaction I have shown. Similarly, one more example will do. If I take NaNO3 molten, then what product do you expect? So, I have Na plus, I have NO3 minus. So, at cathode, now there is no water, molten it is. So, Na plus will undergo reduction to deposit as sodium solid. And at anode, NO3 minus, right, will liberate electron, will give NO2 and O2. You understand that? Plus 2 electrons. So, whenever you electrolyze sodium nitrate or any salt which is having nitrate ion, it will produce two gases, NO2 and O2. I hope this lecture is clear to you, students.